Hello, my name is Yuwen. I'm a PhD student at the University of Notre Dame. Today, I'm here to present to you our case study this year, AI is not enough, a hybrid technical approach to AI adoption in UI linting with heuristics. Um, it was done when I was a student researcher at Google during the period of July to October 2023, just to set the technical feasibility around the project. And this was done with my great collaborators at Google Material Design, namely Tiffany, Shona, Jamie, Clara, and Frank. So this whole project is centered around this idea of design systems. Design systems are used in large corporations containing usually multiple different design products. And they are used to ensure the consistency and scalability of design across the whole organization. Design systems, you can essentially think of them as design component libraries as well as design guidelines. And they provide a consistent look and feel for designers to use their products so that all different products can conform to a similar visual style, branding style, as well as usability standard. But similar to a lot of centralized systems, it's really hard to ensure that all product teams conform to design system guidelines. So, for example, at Google, we have material design, and we have all different sorts of products that uses material design as the design system. But there definitely will be violations for places where the design does not entirely conform to material guidelines. So there might be usability issues or there might be styling issues that we want to correct. And looking for these design guideline violation is often called UI linting. So UI linting is usually done in mainly two ways in the past work. Let's take a look at this example right here. For a bottom navigation bar, material design guideline says a bottom navigation bar should have 3 to 5 destinations, and each destination should have equal importance to each other. So if we look at here, it has 4 destinations, and each one has an equal importance. When we're looking for violations in bottom navigation bars, one way we can do it is to use just heuristics. We can parse out the hierarchical structure of this bottom navigation bar and check, say, if a bottom navigation bar has more than 5 or less than 3 destinations, that's a violation. If not all navbar destinations have the same width, that's also a violation. And more recently, researchers have looked into how to use deep learning to solve this problem. So when you do a deep learning based UI linting, you usually take a vision or multi-model deep learning model and input a whole bunch of positive and negative examples of components or screenshots, meaning, components that conform to the guidelines versus components that do not conform to the guidelines. Shove them into the model, have the model learn the differences, and the model will be able to an extent, determine whether a new example you show the model conforms or violates a piece of design guideline. And in this case study, our question is essentially, now that we have more capable, larger scale multi-model generative AI models like Gemini, can we use Gemini to do essentially this UI linting task? So we started off with understanding designers' needs when it comes to UI linting. We had a 3-day in-person workshop with 2 UX designers who have been working on UI linting for a while, and 2 UX researchers who are also familiar with this matter, just to get a general understanding, a basic understanding of the requirements designers have when it comes to UI linting. We started to do iterative prototyping just to understand the technical feasibilities of different approaches, as well as elicit feedback from designers. If you haven't worked with UI data before, it's essentially 2 different modalities. The first one is like the one shown on the left. It's a screenshot, it's an image. And often these screenshots are accompanied by hierarchical structural information in a format of usually XML or HTML, like what we have on the right. So imagery and textual, these are pretty much the 2 different modalities we can use for UI. And that's exactly what we used. In our iterative prototyping processes, we took the app screens as the images, as well as the text hierarchical code. We took some design guidelines that we care about from the material official websites. And we pretty much played around with Gemini to prototype the experience of using it for UI linting, as well as using some more traditional computer vision algorithms in Colab to test out the capabilities of these algorithms too. And we create a really tight feedback loop with designers. Whenever we have some really promising results, we show them to designers to see if they like the result or not, and where they think we can improve. And after different rounds of iterative prototyping with different technical approaches, we concluded three main designer needs when it comes to UI linting. The first one is designers really want to have high precision and pixel level scrutiny when it comes to UI linting. A lot of UI design is very detailed. If a linting result says, the bottom navigation bar is too tall by 8 pixels, while in fact it's too tall by 12 pixels, that is wrong, and it's going to create so much communication overhead. I might as well do it by myself as a designer manually instead of having an AI do it for me. So hallucination is really bad in UI linting. And the second thing is, very similarly, designers want to have evidence-based linting grounded in all of the material guidelines. If it does not conform to the material guidelines, so very similar to the pixel level difference thing, if it says it's conforming to the guideline while it's not, or vice versa, that's going to create a lot of headache for material design to communicate that back to the product team. And the third one is designers really need explanation of violation and the response so that they can hand off this smoothly to the product team instead of having to explain the violations themselves again. So considering all of these needs, combined with all of our experience in the prototyping processes earlier, we came up with this final linting pipeline design using large language models and heuristics. And let's take a look. So this pipeline really has three modules. The first module on the left in blue here takes in the screen view hierarchies, as well as the screenshots, and use a set of heuristics to parse out components that we care about and their attributes in a semantically meaningful way. So in the view hierarchies, we'll have all of the elements that we have on the screen, but there are a set of components we want to check for, and we only want to check for certain attributes that exist in the material guidelines. Pretty much, we handcraft heuristics to parse out these components and their attributes to more easily feed them into large language models. And the second component essentially serves as a retrieval augmented generation component. This module takes the design guidelines we found on material.io, extract the relevant pieces that we care about for the components we want to check for as sort of a grounding evidence for the large language model to do the linting on. And we pretty much take both of these and put it into a large language model. Nowadays, we can do it for Gemini and have it generate a report saying, these are the violations and here are why they violated the exact guidelines on the official website, which designers can directly take and move that back to the product team, say, maybe you want to correct these. So these are all good, but there are definitely areas that we can improve further. What we were doing were essentially checking for the attributes, the static, positions and sizes of the components. In the future, we also want to do more linting that are based on contextual information about a design. So for example, right here, checkboxes should be used in different contexts than the toggles. In this example, it's obviously more appropriate to use checkboxes, but these sort of linting will not be possible until the AI models understand design concepts pretty well. And the second future consideration is we want to go beyond static UIs and also lint for the interaction patterns. So for example, when we have hierarchical checkboxes, the interaction should follow this intuitive pattern that we see in this video. If the interaction does not follow this pattern, which is kind of recommended by material, that is violation. We want to flag it out. So that is pretty much it. Thank you very much. And feel free to let me know if you have any questions using the contact on the slide. Thank you very much.